Good afternoon. Let's talk a little bit more about polynomial function. So, we will start with talking regarding zeros of a polynomial function and their multiplicity. Okay. Any polynomial function can be written in this format. Well, looks like a little scary. This is a factor and this is the exponent of the factor, another factor and exponent of the second factor, and so many such factors, so many exponent. Well, what should happen is if we add the exponent n1 plus n2 plus up to n to nk, if we add the exponent, then we should get the degree of the polynomial. If a polynomial is in this form, these numbers a1, a2 and ak, the numbers a1, a2 and ak, all these numbers are called the zero of the polynomial. The reason we call them zero of the polynomial is if we replace x by, if we replace in this formula, if we replace x by any of this number a1, a2 or ak, the result going to be 0. For example, if I replace x by a1, a1 minus a1, this will be 0, 0 raised to the anything is 0, and if 0 multiplies anything else, the result going to be 0. Well, I will want to write a formula here, so these things will not be big. Let us say we have x minus 2 to the third and x minus 1. If this is our polynomial, this is raised to the 1, so degree of this polynomial will be 3 plus 1, this is 4. So, this is a fourth degree polynomial. There are two zeros, one of them is 2, another is 1. Now, the two things are same, zeros of the polynomial 2 and 1, and if we have to solve, let us say this equation x minus 2 to the third and x minus 1 equal to 0. We have a new equation, we call this equation a polynomial equation. If we solve this equation, we find solution to this equation, or sometimes we call root of this equation. If we solve this, we are going to end up getting x equal to 2 and x equal to 1. So, basically zeros of the polynomial function and the roots are the solution of the polynomial equation, they are same. This exponent 3 and 1, they are called multiplicities. These are multiplicities. So, I can say 2 is a 0 of this function and the multiplicity of 2 is 3. Similarly, 1 is a 0 of this function and multiplicity of 1 is 2. 2 is a 0 of multiplicity 3 and 1 is a 0 of multiplicity 1. Well, this multiplicity will be some integers, and this is one fact we always need to realize. If the multiplicity of a 0 is even, the even multiplicity indicates the graph touches the x axis and turns around, where the odd multiplicity indicates the graph crosses at this 0. Well, let me use the previous example and let us see what do I mean by that. So, I have x minus 3 raised to the third, x minus 2 raised to the third and x minus 1. So, x minus 2 raised to the third and x minus 1, nothing means raised to the 1. So, here the zeros of these polynomials, these are 2 and 1. These are the zeros, and multiplicity of 2 is 3, the exponent of the multiplicity of 1 is 1. And if I try to sketch the graph of this function, what should happen is the graph should be crossing, let us say this is 0, this is 1, this is 2, this is 3, this is 4. The graph should be crossing x axis because both the multiplicity are odd. This is the odd number, this is the odd number. Since the multiplicity are odd, the graph should be crossing x axis either this way or this way at 2, and the same thing either this way or this way at 1. It should be crossing. Well, let us look at another example. Let us say another example, let us say f of x equals, I will just do a little modification here, x plus 2 raised to the 4th, and let us say x minus 1 raised to the 3. Now, zeros of this polynomial are negative 2 and positive 1. Observe, I am changing the sign of this number. This is positive 2, so the 0 is negative 2. This is negative 1, so the 0 is positive 1. In this example, this was negative 2, 0 is positive 2, negative 1, positive 1. So, we change the sign from the factor. Now, multiplicity, if we think of the multiplicity for negative 2 is 4, the exponent is 4, and multiplicity for 1 is 3. 4 is even, 3 is odd. So, if we sketch the graph of this function, let us say this is negative 2, this is 0, let us say this is 1, this is 2, this is 3. What should happen is at even multiplicity, the graph might, the function might do this. It will come around 0, it will touch at 0, and it will turn around either this way, or this is also possible. We need to know the end behavior if you want to know which exactly is, but one of the two should happen. Similarly, the multiplicity of the 0, 1 is 3. This is an odd number. So, at 1 either the graph should do this or it should do this. Okay, let us look at one more example. Suppose we want to solve this question. So, we want to find the zeros and we want to identify the multiplicity, and we want to determine whether the graph crosses or touches the x axis at those 0, and then we would like to sketch the graph. So, this is kind of the complete work. So, let us start with the zeros. 0 is from this one, we have x plus 1 half. So, one of the 0 is negative 1 half, and here is x minus 5, the other 0 is 5. So, this tells me if I want to sketch the graph of this function, this tells me if this is 0 and let us say this is let us say this is 1. So, 1 half should be somewhere here. So, this is 1 half, this is negative 1. So, this is negative 1 half. Now, if I want to sketch the graph should go through this point, either touching it or crossing it, and similarly this is 1, 2, 3, 4, let us say 5, 6, something like this. Now, the graph should go from this point as well. We will identify either the graph will cross or just touch and turn around at that 0. In order to identify that, we need to know the multiplicity. The multiplicity of negative 1 half is 4. The multiplicity of 5 is 3. The exponents are the multiplicity. That means this is an even number, this is an even number, this is odd number. Now, if we could decide the end behavior of this polynomial function, we can graph a good sketch of this polynomial. So, let us think of the end behavior. In order to know the end behavior, we already know we need to know two things. We need to know the degree and the leading coefficient. So, we need to know the degree and we need to know the leading coefficient. As I already mentioned, degree is nothing more than sum of the exponent. Here is 4, here is 3, 4 plus 3 is 7. So, this is 7 degree, and leading coefficient is, see, here is minus 4 multiplies 1, that multiplies 1. So, the leading coefficient should be minus 4. Minus 4 multiplies x to give us minus x, and that minus 1, and that there is plus 1. So, altogether we will get minus 4 as the leading coefficient. This is 7 is odd degree and the leading coefficient is negative. So, if the degree is odd and the leading coefficient is negative, degree is odd, leading coefficient is negative, then we know that the graph should behave, should come from the positive infinity and it should go, I believe, to positive infinity. I forgot the pattern, let us check it. So, we want to graph degree odd, so x to the 3, and the leading coefficient is negative. So, I will just make it negative. So, the graph will come from the positive infinity, it will come from the positive infinity and it will go towards the negative infinity. So, the end behavior should look like this, coming from the positive infinity and going to the negative infinity. So, now if I want to sketch this graph, at negative 1/2 it is even, the graph is coming from this way, the graph is coming from this way, it will come up to negative 1. Since the multiplicity is even, it cannot cross, so it will just turn around, it will just turn around, it will just turn around and go again back to this 0. Multiplicity of 5, multiplicity of 5 is 3, so it will be crossing x axis at this point and it will be going that way. This is the rough sketch of the graph of this polynomial function. So, basically, in order to get a rough sketch of a polynomial function, we need to know the zeros, we need to know the multiplicity of the zeros, and we need to know the end behavior. Okay, let us do the same thing for this example. Well, unfortunately, in this example, the polynomial is not given in the factored form. So, we will need to factor it out and we will write down this polynomial as product of several factors. So, let us factor this out. In order to factor this polynomial, we will factor the largest common factor. Here is x square, here is x cubed, x to the 4th. So, we can factor x square out of everything. From x to the 4, x square is taken out, x square is left, minus remains minus, plus remains plus. From x cubed, x square is taken out, 1x is left, 4 remains 4. From 4x square, x square is taken out, so only negative 4 is left. Well, in fact, let us factor the negative also out. If we factor the negative out, this negative will change into positive, this is negative and this change into positive. Factoring a negative sign means change the sign of each quantity. Now, this can be again factored, and well, the product is 4 and the sum is negative 4. So, if you factor it, we will get x minus 2, x minus 2 That means basically we can write x square and x minus 2 raised to the 2, x minus 2 times x minus 2 is raised to the x minus 2 raised to the 2. So, we factor the polynomial. Well, in fact, the first factor can be written as x square can be written as x minus 0 square, x minus 0 is x itself. So, in order to make it nicer looking, I will write down as x minus 0 square. So, the given polynomial is factored. Now, in order to sketch the graph, we will do as before, we will find the zeros of this, we will write down the multiplicity, and then we will note the end behavior. If I have these three information, we can sketch, we can have a rough sketch of this polynomial. Zeros of the polynomial will come out of this factor, x minus 0 is one of the factor, so one of the 0 should be 0 itself. X minus 2 is another factor, so another 0 should be 2. The exponent of this first factor containing 0 is 2, so the multiplicity of 0 is 2. The exponent of the factor containing 2 is 2, so the multiplicity is 2. Both the multiplicity are even. So, at both 0, the graph cannot cross x axis, it will just come, touch over there, bend back and go other way. Now, let us think of the end behavior. End behavior, the degree is even. So, the degree is even. So, even degree. So, this is the situation, we have even degree and negative leading coefficient. Even degree, negative leading coefficient will indicate it will come from the negative infinity and it will go to the negative infinity. So, this is the end behavior of this function. So, if I want to sketch this something like this. So, this is 0, let us say, this is negative 1, this is positive 1, this is positive 2, this is positive 3 and let us say negative 2 here. So, it will come from negative infinity, it will be coming from somewhere here, something like this, and when it reaches 0, it will just touch at 0 and bounce back, and it has to touch 2 also. So, it will go back again, it will go back again, it will touch at 2, it cannot cross and again bounce back and go this way. So, this is the kind of rough sketch of that polynomial. So, now we know we can find zeros of the polynomial, we can identify the multiplicity of the polynomial. Together with some more extra information, we can sketch the graph of the polynomial as well.